Okay, so let me share the screen on that. So hope everyone can see my screen. So this is how the kariRS IDE or the Web IDE looks like. So the moment you open it, so currently you are having the preview version. So the moment you open it, it will already come with this sketch for kariRS for the code for the sketch code for kariRS. So you don't have to write it from scratch. Let me admit someone. Yes, so this is how it will look like. Now here, this you can see this indicator. Yes, so you can see there is this indicator over here, this green one here. So this one, for example, if I could reload this page, you can see it is red, then it turns green. So when it is green, it means that you are connected to the kariRS server, which is the one that compiles your code. So if you find out you open this ID and you find that it is red, then you have to wait a couple of minutes until it turns green. When it is red, then any code you write here cannot be compiled. And it's very important that I explain that one. So this is an indicator. It's not just there. It's just a it is not just a decorator in the website. So it is what tells you whether you are connected to the kariRS backend server. So the moment it is green, it means you can be able to compile your code. So this is where you write your code. This is the editor where you write your code. You can write as much as you want. And then here is the console. You can always increase the console like this. This is where you will be doing your debugging. So this is where you'll be getting the logs and you can debug. Same way as how you write the code in VS Code, or the way you would write kariRS code natively in your machine. This is the same way that you can be able to debug, see the logs and everything in the Web IDE. So now currently, so if for example, we're still having some people who are joining us, so they're allowing me to admit them. Okay, so okay, so that is it. So this is how it is like. So in order to, so currently the way that we have the Web ID working, because it is a very good to understand what is actually happening. I would like to show the illustration, because there are times you'll find it that this indicator won't turn green immediately. It might stay at the red zone for around 7 minutes. For example, if the ID has been not has not the kariRS server has not been receiving any traffic, then it might go into sleep mode. So at that point, it might take up to around 7 minutes for it to wake up. So this is what shows you whether it is on or off. So whenever it is green, you know very well that you are connected to the kariRS web server. Then currently the Web IDE support 3 boards, and more will be on the way. So we have the Mega, the Uno, and the Nano. They are all supported, and it has these options. You can verify your code, but the recommended way to verify your code is to compile it and debug from these logs. These ones will give you the best accuracy. And then after compiling, this is the next thing, is that you can be able to download your compiled binary, which you can then upload later. And that is what I want us to discuss and understand what really is happening. So before we even write any code or compile anything, I just want to show you a small sketch. Is not precisely that it's not precisely that you have to memorize that, but it's good to illustrate to you what actually or how this IDE works, so that when you are using it, you know what you realize if there is any, as the compilation occurs, if this taking time, you can realize what is actually happening. So I'll share the, let me share, uh, I'll take you to somewhere else. Let me show you. Yes, okay. I hope everyone can see my screen. Someone to confirm you can still see my screen. Okay, thank you for the confirmation. So this is what we have. So we have, uh, so this is our IDE. I will use just an illustration before we even use it, so that you can, it's just good that you understand. So this is our IDE. This is where you write your code and everything. And then we could give a session that this is a kariRS server. This one is what has the runtime environment. It has the runtime environment, and it is what compiles your code. So what happens is that when you write your code in the IDE, when you write your code in the IDE, so here is where you have your code, and you click on compile, the IDE sends the code to the server. Basically, that is what happens. So the IDE sends the code to the server. So the server compiles the code, and then it sends you back your program. But before it sends you the program, it has to do the compilation. Now, during the compilation, the server sends you the logs, the debug logs. So that is what you will see in the console. That is what the console receives. The console is that place where you'll be, I've just shown you where you'll be debugging your code. You'll be seeing what is happening back in the server. So the moment you open your IDE, and let's say the IDE has been sitting idle, not being used, during that time the server goes to sleep mode. So when you open your IDE, the indicator will be red. But after some time, because when you open the IDE, it sends a connection to the, it sends a connection signal to the server to tell it, hey, wake up, we have someone who wants to program and use your services. So that moment, the server will take around roughly 6 to 7 minutes, and it will wake up, and you'll see the indicator go to green. So that is very important to understand, because sometimes you might spin up the ID, and then you are wondering why your code did not compile right away. Maybe you had a code you had written and you're just copy pasting it there, and you are wondering what's not happening. As well, if the indicator is red, wait for it to turn to green. So the kariRS server sends you the logs, and then it sends you the binary file, which is a hex file. We'll be seeing what is we'll be understanding what is the hex file and what is actually happening. So I hope that is clear. So I can just clear this. Yeah, so that is what would actually happen. So when you compile your code, so today we'll be looking much more of what happens. So even if you're coming from Arduino or anywhere, this is something that applies. So when you compile your code, so we are coming from the source code. So the moment you hit compile, we come from the source code, and then your code is compiled to a binary file known as an ELF file, which has more information, more not just your binary data, but it has more even debug information and whatever. So then after getting an ELF file, we then that is stripped down of any other metadata, and we get a hex file. So a hex file is just a binary file which is encoded in hexadecimal format. So that is what you get. This is what you will be downloading from the server. And if you are using a microcontroller, any MCU, uh, I hope that is understood. So let's go down. So anytime you have your microcontroller like this one, which is an Arduino, or even, let's not say Arduino. Arduino is a framework. Any AVR, they are known as AVR microcontrollers. The likes of Akina Uno, the Atmega 328P, the ones that we are using, they run on the hex files. So if you have a hex file, you can upload it to the MCU. That's why we are able to write code from C. We can write it in C++, we can write it in Rust, we can also go to Python or any other supported language, but in the end the MCU doesn't see that. It doesn't care whether you wrote with C, C++ or Rust. All it knows is that it needs to get a hex file. All these codes will need to be broken down into a hex file. That is why even if we write code in Rust, someone else writes it in C, someone else writes in C++, someone else uses the Arduino framework, we will all have a hex file at the end of it all. So I hope now this will enable you to understand how we are able to be able to compile code online, because now with this IDE, you can just even program using your mobile phone and download the hex file, which you can then upload to your microcontroller later. This means even if you are commuting, maybe you can just program, debug, and test your hardware code from even any device that you have that has access to the internet. So I hope that is understood. Before now we go to the IDE. Is there anyone who has a question up to that point, or any doubt or something that appears confusing?
Can I just ask first about the Python section? Because Python, I think, is an interpreted language, isn't it?
Yes. Okay, yes, I see what. Yes, go ahead.
Yeah. So obviously, your system doesn't do Python, does it? So, but when you do Python, I think the MCU has the Python interpreter on board, doesn't it? How does it operate with Python?
Okay, just a moment. So you said you have the source code, and we have the hex file. And so the issue was on Python. And actually in this point it's not Python but MicroPython, because Python itself cannot run on these MCUs. So basically, Python is an interpreter language, and uh, it is good that you've asked this question of how these would end up into this. And the thing is that literally, I mentioned Python, but in the real sense, here we are not using Python. It is good that you've asked because it could confuse some people. So I think that was my mistake on the end to mention that. But here the MCUs we are using or the platform we are in doesn't support Python, so we can't actually get a hex file. But all the other languages I've mentioned, the likes of kariRS, C, C++, and also the Arduino framework, which is basically C, C++, they can all be compiled to hex file. Have I answered your question?
Yeah. Obviously, the MCU requires a binary file in
Yeah,
assembler, basically.
yeah. Okay. I think it was nice that you pointed that out, and it's a good thing because again, this is not just a presentation; it's a conversation we are having together. So, anyone else who has a question? Okay, so we just jump to the IDE. So, okay, by default it is choosing the mega board, but today we'll be using the nano board. Today I want us to do something different, so we go to the nano board. So let's write some code. But before we write code, because I want.
There's a question in the chat.
Oh, sorry. Let me see. Oh, Naim. Naim, you are so much welcome. So here we are discussing about kariRS, which is a Rust embedded framework. That means it is a framework, or rather like a language. It is it is based on Rust programming language, and we use it to program microcontrollers, like to build stuff that can be used in robotics, IoT. That those are the things that we are talking about. And today we are looking at how we can write those programs from anywhere, like from the internet, and get the binary file which we can upload in a microcontroller, and it can be able to do what we want. So that is what we are basically looking at. How can we write this code from anywhere and have and get the compiled code and put it in our microcontrollers and get, if it's a robot we are programming, if it's a RC robot car or whatever we want to do, or it is a project or a prototype we are building, that we can be able to use this framework to build such projects. So that is what we are basically looking, and our main aim is how can we write that code from anywhere, from a mobile phone, from a tablet, from a PC, from a laptop, from anywhere, without needing to have configured the environment for this framework to work. Naim, have I answered your question or is still not clear? Yes, pardon? Okay, you're welcome. So literally you can see the indicator right now is green, and as you write your code you might see it turn red and then green again. You basically don't have to worry. Whenever, as well as you're in the you have opened, you have already opened the IDE, you just do your work and let kariRS handle the rest. So literally we have this sketch. Now for the ones who are completely new, I don't want you to be lost. So when you find this sketch, this is where you write your code. right? We call it setup code here. This is where you write your code, and here write your loop. This is where you write your loop logic. I mean your program logic, the one that will be executed by the microcontroller continuously. This is where you write your logic. So here you write your setup code. The setup code is the code that we learn once, like configuring the pins, maybe instantiating classes and all that. We'll be seeing that one in a while. This is where you do it, okay? And then this is where you write your loop logic. Now today we'll be using the nano board, and you'll be finding out why I've selected nano. And most of the session we've been doing mega. I prefer using mega, but today we'll be using the nano board. And I want us to first get to know. I want to first connect the nano board to my computer. Let me connect it. No. Now, if you have a question, you'll just unmute your mic and ask. So I want to share the whole screen, so I might not be able to see your charts. I want to share the whole screen so that we can now move. Yes, like that. You can still see my screen clearly. Got someone to confirm? I'm sharing the entire screen.
Yeah, it's good.
Okay, okay, okay. Thank you. So let me go to the terminal and clear this. I want to start. Let me start another PowerShell. Yeah. So I want us to know which port in my Arduino Nano is in. So I will type carry detect. Now, for those ones who are completely new, do not be scared about the commands I'm writing here or whatever. This one, we shall discuss it, and already we've discussed it in the previous sessions. I'll be sharing the recordings and also the link to the WhatsApp group where you can be able to ask questions and get answers. Or you can also ask me questions directly in the on WhatsApp. I'll still reply to you. So I'll learn carry detects. And you can see here that it is in COM6. It is on this port known as COM6. And yes, uh, okay, let me admit someone. Just a minute, guys. So admit. Mercy, you're welcome. So so you can see that the board is on COM6. Now I want us to know whether I want us just to open a monitor from that in that port. We see whether there's any data that is being sent from that microcontroller. So carry monitor. Yes, let's see. Um, okay, literally we need to be in a. Oh, I don't need to give you an answer. Can anyone try to guess why we got an error? If you have been attending the sessions, can anyone, maybe from what you can see, can anyone who has been attending the sessions be able to identify why it threw an error when I typed that command?
You're not in the right subdirectory.
Yeah, exactly. I'm not in a. For you to learn this command, you have to be in, in a supported kariRS project folder or directory. So if you're not in it, it will basically panic. That's why you see it tells you that it failed to load the kari.toml. It doesn't know. Okay, you told it to run this command. It needs a configuration file. Now it doesn't find this file, so it panics. It ends up giving you an error. So just end up to a varied, any varied uh, any varied folder. So for example, there's this project. It is an RF harvester. So it's a very interesting project. Maybe we discuss it sometime. I did it using kariRS. It was a, we'll see it later on. So it is this one is a varied kariRS folder. So you can try to learn kari monitor, and it says you need to specify port in the CLI. So let's specify the port. We are using COM6 like that, and we don't see anything. Literally, we don't see anything. So let's try changing the boundlet. Maybe it will show us something. Let's give it the most used boundlet, because it's a nano actually, but we literally see there is nothing. So we want to write a code which will be sending data to here. Last time we looked at serial, so we'll be writing a serial code so that we see whether our MCU here will be able to change. So I wanted to learn this one first, so that no one can have doubt of maybe he had written that code. No. So we see that literally there isn't anything we are getting. So let me kill that process and let's clear. Now back to our IDE. So let me delete this, and let me also delete this. Now to initialize serial communication, we use serial like that hyphen. We'll be using the baud rate of 9600. That is the most supported baud rate in AVR microcontrollers. So if anyone is wondering why I took 9600, and basically that is it. And now we can first print something. We can say when we want to print something in the serial monitor using kariRS, we use this function or macro. Call it kprintln like that. Then we shall basically say hello from kariRS Web IDE. Yes, I think that one sounds cool. You are basically saying hello from kariRS Web IDE. Okay. Uh, we could basically now try to take something that will repeat. Let's create something that will is non-blocking. Let's write a non-blocking code here. Don't worry if this feels alien to you. Uh, the first thing today is to just be able to understand how to use the kariRS Web IDE. So don't be so much scared of the syntax I'm writing or anything. So right here we can say, we can write here compiled code from kariRS Web IDE. Maybe we could add an iteration count. Web IDE, we could maybe add num, just something. It's not that necessarily. Maybe we could add a variable like count. So that one we can come here and create a variable. Let's mute count equivalent to 0, like that one. And then inside of here we could do count plus equals to 1. Yes, like that. Do plus plus. I don't know that plus support that, but you can just Or yes, let's see that if Rust does not support plus plus, we can be able to even, it will also help us to see how errors, how to identify errors in this in the IDE. So I think that is good to go. We want this one. 500 is too fast. We can go with 1000 after this one. This 1000 milliseconds. So basically it's 1 second. So this will only be executed after each 1 second. I think that is. So now the moment I hit compile, this code will be sent to the server. So let's see what happens. So I want you to observe the console. Let me extend it a bit like that. I hope you can still see it like that. Now that is our code. So I've extended the console. You can usually extend it to how much you want, like that, or like, okay, to which level you want. So I can extend it up to that level. That's pretty good. So then I will click compile, and you can see immediately it tells me compiling code, then compiling code by server. These messages here are not coming from the IDE itself. It is getting these messages from the server. So all these logs are coming from the server. So don't think they are coming from the IDE itself. No, they are coming from the server. Now the server is basically compiling. And now here's something you need to understand. When you send this code to the server, remember, currently this IDE does not know you. It does not know, there's no place that you are being asked for an account. There's no place you're being asked to give any of your information. You're just opening the IDE and telling it to compile your code. So basically what happens when you send your code, the server has to create a project and configure it and then compile your code in that project. Now you can imagine if you are having so many people sending the request to the same server, so it has to build so many projects. So it can't rely on like one project folder. So it has to create, for each user there's, each user has his own project folder. So the compilation time will be equivalent to the compilation time which you get when you compile a kariRS project folder for the first time. And we all know the first time you compile a kariRS project folder, it takes a bit of more time than the subsequent compilations, because it is compiling the other supporting binaries. Like you can see these libraries that are being compiled here. So this is the cost that you pay for using the IDE and not downloading the kariRS. But again, it's just a short while and your code will be fully compiled. So it's good to mention that. So you might wonder, why is the compilation slower than the native one? It's not that it's slower, it's because each time you send each time you send you click on compilation, it has to build a new folder and uh, and compile everything for you. So that is what the server is currently doing, and you can see it is on real time. It is sending back the logs on real time, as if you are using your as if you are on your local machine. You are getting the logs on real time, and you can see it's moving fast. Because actually, let me scroll. I'm the one who is. Let me scroll fast. You can see it's really throwing us the logs very fast. So now this is what you see. We get compilation failed. It did give us a notification, and this is what I wanted. I did this on purpose. So you see, it tells you what Rust has no postfix increment operator. So Rust does not support count plus plus. So this is one of the things that so you see, it tells you the error, and it also tells you how to correct the error. So this point where I had written plus or is equals to 1, then I changed to plus plus, that is the error. So it tells you need to change it to this one. So literally you can see this is how you do the debugging. It tells you what happened and how to fix it. So that's how friendly it is. Now if you scroll down here to the, you can see error compilation failed, and tells you that it could not compile because of 3 previous errors. So you can check which are those errors but basically it is this error which I've shown you that has caused that. So let's fix this error and see what will happen. So this is plus or is equals to 1, like that. So now let's click on compile and let's see what happens. Then right now you can even follow up with, you can be following up by just opening a tab and just type in this URL. Let me share it in the, but I think you can see just kariRS -id.netlify.app. So this still a preview version of the kariRS ID. So you can access it on that URL currently. So still compiling. So you can see for each compilation, you pay the cost of compiling, similar to as if you are creating a new project for each time you change your code. But again, the benefit of being able to compile on any device outweighs that bit of the extra time you have to wait for the compilation. And you can see that it's relatively not that long. So let's wait for it to compile. So it's compiling. I'll get in the logs as the server compiles the code. Yeah, you can see it's doing it in embedded, kariRS, dips, AVR, hold generic. It's basically compiling all these things in kariRS, which support your code. So this is what is happening. You can see kariRS. So let it finish. So it says compilation failed. So let's see what happens. So I hope you guys are learning from this. Uh, uh, this is doing so that you can learn how to do debugging here. So now we are getting cannot find value task 1 in this scope. You see all that, and you realize the main issue why it failed. Let's go back to these logs. There's so much, but this you can see this one expected function found macro carry async. So the issue is because, so you see it shows you the issue and then it tells you how to fix the issue. So I think this is the best thing. You don't have to think of how should I solve it. You have already been given the solution, because the server that is compiling the code has kariRS runtime environment. So it's and which is basically together with the Rust toolchain. So it gives you very good solutions of how to solve it. So the issue here in our code is because kariasync is a macro, so it needs something like it needs this, similar to how we are lighting these ones, because most of these functions are not actually functions, they are macros. So you needed to add that one. Let's see whether there's another issue. So it tells you the code failed because of two previous errors, but I can tell you that it's basically because of missing this, because if you miss this, it will not understand what is task 1. It will not understand what it is. So let's see whether it's still correct, and let's click on compile. So you can see how it's easy to debug code in this IDE. So don't worry about why I'm doing this intentionally so that you can see how to debug, because again, if we just compile right away without errors, how will we even show how to debug? So let it compile, and let's see. So this console, you can even increase it to that level. You can see our logs. And by the way, as the code compiles, this same editor that you're using here has got the same. If you are very good with VS Code, if you click like this, you can be able to access the same palette that you find in the VS Code editor. You can see it. You can be able to access. So if you are used to this kind of functions in the same that you find in VS Code, they are also here in the kariRS editor. So you can be able to use them for whatever reason. And yeah, if for example you wanted to save this code in your computer, just click Control S, and literally you can choose how to save your code, or you can, if you wanted to, okay, basically whatever you can do in the most of the functionality you are able to access the VS Code editor, you can be able to get them here. So let's check whether we are done with the compilation. Not yet. So don't, these many warnings you're seeing here are because of the fact that kariRS is still in. You can see it compiled successfully. They're because kariRS is still in development. So you can see here success, compilation finished. Though you also show that pop-up that came out to tell us that we had completely finished. Now the project was built successfully, and we are told that the hex file was created. And the thing is, after the server creates for you this project, it forgets everything, it erases everything. So now let's see whether we have the program. So if for real a program was sent, if I click on download, I should be able to get it. So if this is something I should have mentioned, and I'm mentioning it right now. If your code fails here and you click download, you won't be able to get any file, because if your code failed here, the server would not send any file. It would not be able to compile any file. But if your code succeeded, if it truly succeeded, you will have a file to download from here. So let's click on download, and you see it tells us no hex file available for download. Please compile the code first. And okay, we have already, the logs have already gone. I could have shown you what was the false alarm that caused this, but let's compile again, and you get to see what I'm trying, what the issue is. So let's tell it to compile again for the nano board. Yes. Someone says they are not in the meet. No. Someone is waiting to be admitted. Oh, someone says the URL is not working. Okay, let me send you the URL. And kindly unmute your mic, because if you send something in here in the text, I might not be able to see. When I'm sharing the whole screen, I might not be able to see it. So there is the URL. I can see also Paul has already sent it. So that's the URL. Just open it. Let me confirm that you have not had any. So it says compilation was a success.
You only have the 3 boards.
Yeah, for the ID, it is only supporting 3 boards, but to be adding more boards.
Oh, okay. So the local version has which ones?
The local version
ESP32.
ESP32 is not yet supported in kariRS, but the support will be coming sooner. So this first release first supported the AVL MCUs, and okay, most of the work has been to lay the infrastructure for the kariRS, and that we've seen that I'm first laying a lot of foundation, a lot of the infrastructure for this framework. But again, the framework will be evolving with time. So all those things that you're mentioning are all in consideration, and the development is still ongoing. Yeah, and the feedback I get from you guys is very helpful. it is very helpful when you work with your project. If you find any issue and you give back the feedback, it is a very helpful thing. So let's compile this code again and see why the server did not send out the hex file. So the person who said that the URL was not working, have you been able to access it now? You can unmute your mic and reply if you can hear me. Have you been able to access this same ID that I'm using?
Yeah, he said it's working now.
Okay, okay, thank you.
I got it wrong the first time. I put netlify instead of netlify.
Yeah, it's Netlify.
Netlify.
Yeah.
Not netlify. Dyslexia.
Yeah. Okay. And by the way, if I can mention, when you're using kariRS, basically here we can see we have 3 boards, but actually it's like 2 boards. The reason I can classify them as 2 boards is because uh, the Uno board and the Nano board, they actually use the same microcontroller, which is that Mega 328P. Now, the reason why sometimes you find that we separate the names is because of the time of uploading the code. You can find that in most cases the bootloaders could be different, but in kariRS, the way that we upload the code, even if you were to compile the code for Uno board, it would still work in a Nano board because they are literally the same microcontroller architecture. So let's see. So that way you see, right now I changed to Uno, but even if we even if it was still to be Nano, it would still send us the same hex file. But I've changed to Uno so that we can get to see why the server had not sent us the hex file. So here, the issue is clear. There was a fall in connection when I was still compiling. So now the server requires that we renew the entire connection. And so this is one of the, as we talk of the advantages of using this ID. So you have to ensure that your internet is also stable. So I just copy this. I'll copy this one and renew this like that. Then can choose my board and can tell it to compile. Now, as it does that, let us be discussing on what happens after we get the code from here, because that one is the other thing. Because I want us to have finished covering all that. So what happens after we get let it be compiling. So from here, we need to understand what's next. So So we have our hex file. So how do we get it to our MCU? So here we will use another tool known as kariSpark, because we need to take this hex file and get it inside our MCU. So we will use kariSpark. So this is another tool in the, remember, whatever we are working here on is what we call the kari ecosystem, and kariRS is just part of the tool chain. It's part of the tool of this. Though that kariRS is itself an evolving ecosystem, just new, but it is under this ecosystem. So kariSpark, all these are all tools under this ecosystem. So we'll be using this tool known as kariSpark to get our hex file to the MCU. So now let me take this one up there. So, or let's take it away completely. Now, kariSpark comes in two versions, because again, you have to realize you are working with developers here. So it comes as a CLI tool, and it also comes as a desktop tool. So if you like just working on the terminal, you can get the CLI tool. If you don't want to deal with the terminal or anything, like you just want your stuff with the code ends on the IDE, then you can just use the desktop tool, and we will be using the desktop tool. Although I'll also show you how to use the CLI tool, but this desktop tool is very easy and very friendly to use. So let's check whether our code has finished compiling. It's still compiling, so I'll be launching kariSpark. So like this, kariSpark. You can see I've already installed it. So let's open it. Sorry for that. Yeah, here it is. Yes, here it is kariSpark. You can see it loading. Yes, and here it is. So this version you can check about. It is version 1.0. So this is a tool that I also developed, but it's part of the ecosystem. So this is what will take your code and get it into your MCU. So you can see how the chains, how the tool chain is like. So the everything flows this way. So we have, or let me just take, you can just shorten these ones instead of writing everything. So we have the IDE. So when I like the IDE, so from the IDE we go to kariSpark, and the kariSpark reaches our MCU. So literally that is how. So this one is online. So you download your code locally, you launch kariSpark, and you get your code to the MCU. So this is how the flow is from the IDE to kariSpark to MCU. And we'll be having a session discussing about kariSpark, because it is the tool that was built for much more purposes, and you'll find it is very helpful whether you'll be using kariRS or not, whether you use kariRS or any other framework. This is a very important tool that you can add into your bucket list in your usage. Still waiting for this one to finish. So we can, so literally you can see it did compile. So we can save it as something else. Let me change the name. I can call it uh, Web ID. I mean kariRS Web IDE 1. Let's call it 1 because we might compile another file. kariRS Web IDE 1.hex file. So I click download. You can see it's a very small size. 6 point something KB, roughly 6 kilobytes. So I can click download. Yeah, and it's downloaded. So I can check where it was downloaded. This one I can check the folder. So here it is, kariRS Web IDE 1.hex file. So we want to see how we can get this hex file here into our microcontroller. So literally, you can see that kariSpark is able to detect. Let me take down this. You can see that kariSpark is able to detect where our MCU is connected. So literally, this is a window. This portion here, this one you can see that is grayish here, is like a window where kariSpark desktop displays displays the connected port, and it gives you its logs if any error, success, or whatever. This is where it will give you the information. You see there's many other things here, but for us today we'll be dealing with this upload section. We have the download section, we have transfer. You can see like transfer here, we have parallel options, we have verifications options. All these are very important to understand. For example, even verifying programs, doing transfer. For example, you can transfer code from one board to the other, or from one board to many boards at the same time simultaneously. That is what we call parallel flashing. This tool is that powerful, it can do all that, but we'll have a session dedicated to this actual tool. But today we'll be using its option, which is the upload section. So here we will choose that we are using the nano board. We want to use the nano board, and our programmer, we are using Arduino programmer, because literally we are using the we are using ISP. That is, we are not using the USB ASP. We are using the inbuilt programmer inside the boards. That's why it's usually just called it Arduino. So that is it. We are not doing parallel transfer. If we were programming into many boards, we would just tick this. But because we are programming to one board, we'll leave it like that. Then we click upload, and we will go to where we have downloaded our hex file. It was in, where was it? It was in docs, textures. Yeah, this one, kariRS Web IDE 1.hex, and I click open. So it says that uploading to at mega 328 was a success. Now, if by any means you think that something is wrong, let me just mention so that you can get even a glimpse of what, for example, this function verify does. This one, it downloads the program that is in your microcontroller and compares it with a program that is on your computer to see whether they are the same. So let's see whether when we created upload and it tells us that it has uploaded, let's see whether it did tell us the truth. So that is what we use this one for. So I can come here and say I'm using the nano board, and I say I want to verify. I want to verify against this file that we downloaded. Let's open like that, and you can see it telling us it is verifying that we should wait, and it tells you that verifying from at mega 328p was a success. So meaning that here in upload it did not lie to us. When it says it uploaded, it did upload, and verification has confirmed that for us. So even if we are going to the terminal to confirm, we want to believe that this code we have written here is what we will find, that it will print to us hello from kariRS Web IDE, and then from there it will start printing for us compiled code from kariRS Web IDE num, and then it will start counting 0, 1 up that way. So let's see whether that one is the truth. So we come back, we run kari monitor now on our computer, and see whatever we wrote, hello from kariRS Web IDE, and then we see compiled code Web IDE num 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And literally this code here that is learning from our MCU is the code that we wrote online and was compiled by the server. So literally you have used the server to compile your code, downloaded it, and then use this program known as kariSpark to upload your code, and literally you have your code locally. So you can see the benefit. You can literally be even programming in your phone, and you can set this program into your computer later on and program it. So literally this is what you are able to do. So back to what you have said, you are coming from the IDE, you compile, you download your hex file. So that hex file, you can store it in your computer, and you can then retrieve it later into using kariSpark, and then you put it into the MCU, and then you can run it. Same as what you are seeing us do here. So we have basically all these. You can see the program is already running from our microcontroller, a program that we have written inside the kariRS IDE, literally. So, is there anyone with a question up to there?
Just wondering, is the server more powerful than my local machine, or not really, for compilation purposes?
For compilation purposes.
Hmm.
Uh,
Do you know what the parameters are of the server you selected?
okay. Literally, on that point, you see, when you ask about your machine, every person's machine differs in their processing power. But literally, if we roughly say your machine is maybe y7 or something, we could literally say doing it natively would be better. But at the same time, the time that it takes for you to compile your project for the same time, for the first time on a first machine, is the same that you'll get in the server. The reason you're seeing the server is taking more time is because the server immediately, like right now, when I sent this code, this kariRS code, when I sent it to the server, it was the server created a new project. You have to understand what the server is doing. It created a new project, downloaded all the libraries required, compiled them, and then it sent us the programmed, the compiled binary, and then it erased everything that was there. So each time I click the compile button, that is what the server is doing. So literally the server is a bit faster. It's just that it has to do more work each and every time you click compilation, because again, currently I do not have the luxury of having many project folders sitting in the server waiting just for anyone to come and compile. So it has to create a new one, erase, a new one, compile, set the hex file, erase. So that is what is happening back in the server. Now, literally, if we are having many people doing it at the same time, you can see the server is still powerful than your machine, just that it has to do more work each time you compile. Unlike your machine, whereby you create the project folder for the first time, it compiles, and then it already caches all that. So in the next iteration of compilation, it is just using the cached binaries. So that is the difference. That's why you're seeing we are having more time in compilation. So the server is a bit better, but on a recommendation basis, if you are able to just do it natively, just do it natively. But if you are like, you want to be programming, you are not having access to a good fast computer, or you want to do a project while you are commuting or from any device, then the IDE is better. So have I answered your question or not yet clear?
Yeah, no, basically it's compiling first time every time.
Yes, it is compiling first time
First
every
time
time.
every time. Yeah.
Exactly. That's what's happening with the server.
Do you have minimum requirements for local machine, or anything that Windows or Linux will run on? Obviously, the more RAM and the higher the processor, the faster the run.
Yeah, if we
Does it have?
it's literally as well as your computer can be able to run the Rust, can be able to handle the Rust toolchain. Yes, if it can be able to handle the Rust toolchain, then you have no issues. Yeah. So anyone else with a question? Oh, okay. I'm not seeing. Okay. Okay. Let. Uh, okay. Then we are winding up. We are actually winding up. Okay, I did not know about that. Today's session, I don't want it to be that strong. So basically, I hope you guys understood. So I think there was there was an issue with the selection with the nano board. Uh, I'll be checking on that in the next. That is that's something that can be fixed back in the server, because we saw that the nano wasn't sending us back the hex file. But again, I've shown you that if you select the Uno board, it will work for both the nano and the Uno, because they are using the Atmega 328p microcontroller. So they share the same MCU architecture. And this is the importance of understanding the MCU architecture. The moment you understand how the MCU architecture is, you have no issue with the boards. The boards are just a platform. So literally you've seen the flow, and I hope you can be able to do this. Paul, you should now start, try at least do something kariRS. Maybe it could be important. So we will check into kariSpark next time. You can also have a check maybe by yourself. Here is the GitHub repo for kariSpark. It is also on its first version, so you can see most of the tools in in the Kari ecosystem are in the first version. So the feedback we get, and the feedback correcting the feedback, so that you can be able to see the optimization and the correction, to do even the fixes of bugs and all that. So kariSpark is a much more older tool than kariRS. It came first than kariRS. So it was a tool that you can, if you are coming from Arduino, you can use it. You can use it literally, and it's not tied. It's not like tied in kariRS, but it is now playing a big role in kariRS ecosystem. So you can look at it here. If you wanted to use it in your IDE, it has this kind of a command, kariSpark, like that. Like I can write kariSpark hyphen help, and you can see it. kariSpark is a Kari CLI app for downloading, uploading, and transferring programs between boards. Like this, you'll find out that if, for example, you are a trainer for using Arduino boards, this tool would be like a treasure to you, because if, for example, you had to program like 10 boards, you can just connect them to your to your computer, take the hex file, and send it to all of them, and it will do them simultaneously. If your computer has more cores, the better. So the faster, the more cores that your PC has, the more kariSpark will work faster, and it will be able to even do much more for you. So literally you'll be seen at this. Yes, pardon?
You need a lot of COM ports for that, yeah?
We are saying if
If you're
you,
doing in parallel, you'll need every board needs its own COM port.
yeah, you need, if you are using many boards. Let me correct the statement. Let's say you have a board. Let's use an example with a Mega. You have a Mega 2560, which has a program which you do not have the source code to. Now, if you head up such a board, and you literally need that program to run in other Mega boards that you have. Maybe you have 10 of them, and you want
You
that,
gotta clone it.
and
You gotta clone it.
you want to clone that program. You would connect all those boards to your computer.
But you need a COM port for each board.
Yes, all those components will be displayed here.
But my computer only has a maximum of 4 ports.
4 ports.
They don't, sometimes even the new ones come with only 2 COM ports nowadays.
Oh, Yeah, now, but I
So
think,
you need like you'll need a port expander or something.
yeah, you would need a port expander. But if, for example, let's say your computer supports 4 and you wanted to do 4, or maybe let's just say 2, you have 2, right? You have the master one, the one that has the program, and the one in which you want to clone the program to. So they would both appear here. They would both appear here in this place, and then you would come and select the master. You will come and select the source port here, and you'll come and select the target one, the one you want to clone. And then you select the your architecture, and then you click on transfer. So what it will do, it will clone the program from one port to the other. I hope that is, yeah, okay.
Yeah,
Uh,
and you need sufficient components to do it.
yeah, yeah, that is not yes, you literally need depending on the number of ports you need, you would need the sufficient port to do it.
And I presume eventually you might be able to do on the Wi-Fi phones. You might be able to do over-the-air update
uh yeah, it's also possible to do that.
in future.
Yeah,
Yeah.
yes. Okay, so is there any other question? Okay, if there's no other question, then I think we can wrap up this meeting, and I'll see you next time. So I've provided you guys with the link to kariSpark repo. You can be able to check it out there. Yes, I think I've already sent it. So you can check it out there, and get to learn more about what it entails. So with that, I wish you guys all the best, and let's meet next time.
Thank you, man.
Okay.
Thank you. Thank you.
Okay, thank you.